Introduction to Optimization, Questions for Screen Recording Task, Part 2, Convex Sets and Functions. Question 5. Show that a norm of vector x is a convex function for a general norm. The definition of a norm on a vector space V is a function from the vector space V to the real numbers satisfying the following conditions. The non-negativity. For every vector x, the norm on x is non-negative, and the norm of x is equal 0 if and only if x equals 0. Homogeneity. For every scalar lambda and the vector x, the norm of lambda x equals the absolute value of lambda multiplied by the norm of x. The triangle inequality. The norm of the sum x plus y less or equal the norm of x plus the norm of y. We'll annotate the norm to be a function from the vector space to the real numbers. We will annotate f to be a general norm. X and y will be two vectors of the vector space V, and lambda will be a real number in the segment from 0 to 1. Our solution. F is a general norm on lambda x plus 1 minus lambda y. So by definition, we can write it as a norm of lambda x plus 1 minus lambda y. By the triangle inequality, we know that this expression is less or equal the norm of lambda x plus the norm of 1 minus lambda y. Now, because of the homogeneity property, we know that this expression equals to the absolute value of lambda multiplied by the norm of x plus the absolute value of 1 minus lambda multiplied by the norm of y. Because lambda is a scalar in the segment from 0 to 1, we know that we can cancel the absolute value sign and get that lambda x plus, the scalar lambda multiplied by the norm of x plus 1 minus lambda multiplied by the norm of y. Now, because the norm of x and the norm of y are both defined to be f, we get that this expression equals lambda of fx plus 1 minus lambda fy. So we got the inequality that f of lambda x plus 1 minus lambda y, where lambda in the segment from 0 to 1 is less or equal lambda fx plus 1 minus lambda fy. So by the definition of convexity, we get that f is a convex function. F is a general norm, so we conclude that every norm is convex.